Part 2 of 2.8%. So it's just a little more practice, this time looking for things other than the percent. All right, so you can use percent proportion or percent equation, whichever one you want. I tend to use the proportion. It goes a little faster, or it's easier to show you what I'm doing. All right, so first thing I'm going to do is read the question and label the parts so that I know what I'm looking for. 125% of what number is 17.5? Okay, if you remember, it's part or is over of, which is whole, equals percent over 100. All right, so here's my percent. Of is what I don't know, but that's my whole, and is my part. Okay, so when I plug these all into my proportion, I'll have 17.5 over x equals 125 over 100. Okay, so when I do my cross multiplication, I end up with 1,750 equals 125x. And when I divide by 125, I get x is equal to 14. Okay, this number is smaller than the part because that part was 125%, which is actually more than the 100%. Okay, second practice question. 30% of what number is 12.5? So same thing. 12.5 is my part. Of, or my whole, is what I don't know. And 30 is my percent. So I'll have 12.5 over x equals 30% over 100. Cross multiply gives me 1,250 equals 30x. And divide by 30. It tells me that x is 41 2/3, or 41.6 repeating. All right, this time I'm looking for the part. Okay, so part is what I should be missing. 62% of 168, there's our whole, is what? Okay, so remember, what implies that I don't know that and I need a variable. So part over whole equals percent over 100 tells me that I'm going to need to put my x on the top, 168 on the bottom, and then 62 over 100. Okay, so this time when I multiply, I get 100x equals 168 times 62, 10,468. I'm sorry, 10,416. Divide that by 100. And we find out x is equal to 104.16. Okay, 160% of 4 is what? So x over 4 equals 160 over 100. Okay, so this time my part is going to be bigger than my whole because 160% is bigger than 100%. So when I do my cross multiplying, I get 100x equals 160 times 4. Okay, divide by 100. Tells me that x equals 6.4, which is bigger than our whole number 4, so that is accurate. Okay, now let's apply it to real life. A dress shirt that normally costs $38.50 is on sale for 30% off. What is the sale price of the shirt? Okay, so here's another two-step. The first thing I need to do is figure out what 30% is. Second thing is I'm going to actually take that amount off to get my final amount. Okay, so my whole is $38.50. My percent is 30. It means I'm missing the part. I want to know what 30% is, so 30% has to be across from what I need to know. Okay, so 30 times 38.50 is 1,155, and that's going to be equal to 100x divided by 100. And I find out that 30% is $11.55. Okay, they're not going to let me walk out of the store with a dress shirt only paying $11.55. That's only the amount that I get to take off. So my second step is to start with the whole amount, subtract that 30%, that I get off, and that tells me that I get to walk out of that store with a shirt after paying $26.95. Okay. A family sells a car to a dealership for 60% less than they paid for it. They paid $9,000. For what price did they sell the car? So we need to figure out what 60% is and then actually take it away because they got 60% less than what they paid. Okay, this was the whole amount that they paid. So I'm missing the part. I know the whole. I have a percent, and 100 always goes on the bottom. So 60 times 9,000 gives us 540,000. And that equals 100 times x. Okay, when I divide by 100, I can cancel these zeros. And I see that that leaves me with 5,400. But that's not what they sold it for. That's how much less they got. So I need to take that away from 9,000. That means when they sold their car to a dealership, they only got $3,600, even though they paid $9,000. Okay, a discount store marks up the merchandise it sells by 25%. If the wholesale price is $13, what should be the retail price? This is our whole, here's our percent, and we know that we're going to be adding this time. Okay, so I don't know my part. I know my whole is 13. I know my percent is 25, and I know it's always out of 100. So I have 100x equals 25 times 13. I divide by 100. And that gives me 325. Okay, because it's a markup, I have to add 325 to my whole amount. So 13 plus 325 tells me that the retail price should be $16.25. All right, last concept for today and for this lesson, simple interest. When you go to the bank and you ask to borrow, we're going to use real nice, easy numbers. If I ask to borrow $100 and they tell me that my interest rate is 10%, that's really high, but we'll just use it. That means that I have to pay back $10 every period. Okay, so in this case, if I borrowed somebody $100 and I told them that they had to pay me back with 10% interest every day that they don't pay me back, that means after 2 days, they not only owe me the $100 back, but they owe me $10 for the first day and $10 for the second day, so they now owe me $120. This is simple interest. Okay, vocabulary. Interest is like the extra amount that you have to pay. Principal is your starting amount. Annual rate, R stands for your annual rate as a decimal, but it's going to look like a percent. So that's that 10% I was talking about. It'll look like a percent. You have to turn it into a decimal. And T is your time in years. So that means if they tell you 6 months, you need to put in half for that T. Okay, and the simple interest formula is I equals P times R times T, which I will write on each page. Okay, so our interest will equal the principal times the rate times the time. Okay, we're gonna look for those things, and I always ask that you list each one of them out before you try to solve this. Okay, so you deposit $650 in savings. That's what you're starting with, so that's your principal. It earns a simple interest rate of 5% per year. Okay, 5% is your rate, but if I write that as a decimal, I have to move it 2 places to the left. So 0.05 is what we want for our rate. You want to keep the money in the account for 5 years. That's our time in years. How much interest will you earn? Okay, so that's what we don't know. So now I'm going to plug these into my equation from the top. So I is equal to 650 times 0.05 times 5. When you multiply all three of those things together, you get 162.50, and that's exactly what they're asking for, just how much interest. So that's how much money you're going to earn without doing any work. They're just going to give you that extra 162.50. Okay, this time you deposit 125 in a savings account. Earns a simple interest rate of 1.75% per year, and you earned a total amount of $8.75 in interest. For how long was the money in your account? Okay, we're going to list everything that we can out of this problem. If you deposit 125 to start with, that is your principal. Your interest rate is 1.75%, but I need to turn that into a decimal. Just because it has a decimal in it doesn't mean it's where we need it to be. Right now it's a percent, so I need to move this back 2 places. So I'll get 0.0175. Then it says you earned a total of $8.75 in interest. So our interest is $8.75. And we're wondering for how long was your money in the account. So the T is actually what we don't know. Okay, so we're going to plug that into our equation. So I equals P times R times T. Okay, and then I'm going to erase this a little bit so that we have some more room to work with. Okay, when I multiply 125 times our rate, 125 times 0.0175, that gives me 2.1875 all times T, which means to get T alone, I have to divide by that. And I found out that my time is equal to 4, and it always has to be in years, so this is 4 years. Alright, if you need more practice on this, make sure you ask me, and I can get you some stuff to work with. Otherwise, your assignment for this